Welcome friends to my YouTube channel Sommo Physics. So today I shall prove about the various properties of central forces which I told in the previous lecture, that is lecture number 1 of central force. So let's proceed. Before I shall start, if you don't subscribe my channel, then kindly subscribe this channel, like and share it to your friends, neighbors or relatives. Okay, so let's start. So first property, we told that central force is conservative and work done by this force around a closed path is always zero. How we can prove it? Suppose we consider a particle moves from initial position A to final position B. Okay, the particle lie in a central force field, that is we can write F vector, this is equal to magnitude of F into r cap. This is the central force expression. Now first of all, we have to find out what will be the amount of work done in taking the particle from A to B via the path ACB, and then we have to find out the amount of work done to bring back the particle from B to A via the path BDA. So first take this. First we have to find out this, the amount of work done in taking the particle from A to B via ACB. So what will be the amount of work done in taking the particle from A to B via ACB path by small distance dr? This will be dwACB. This equals to F dot dr. So this is the amount of work done in taking the particle from A to B via ACB path by small distance dr. So we can write as F of r into r cap, and dr, this we can write as mod dr into r cap. So this is simply F of r into dr, and this is nothing but dv. Okay, now what will be the total work done in taking the particle from A to B via ACB path? Now the total work done in taking the particle from A to B, this is simply integration of this, that is A to B dv. Okay, now this can be written as Vb minus Va. So simply we can say that the amount of work done is directly proportional, directly depends upon the initial and final positions, that is Vb minus Va, since V is a function of r only. Okay, now we can write similarly the amount of work done in taking the particle from B to A via the path BDA, that we can write as WBDA. This is simply B to A, that is this is final and this is initial, that means VA minus VB. Now if we add these two terms, then we will find out the total amount of work done around the closed path. So what will be it? The total amount of work done around the closed path will be WACB plus WBDA, which is simply nothing but 0. This is our result. So the central force is conservative, there we see. Okay, and the total work done in taking the particle around a closed path is 0. So this is the first property. Now we have also told that this force can be expressed as the gradient of some scalar potential, and how we can prove it? Now we know that potential energy is a function of position only, that is V equal to xyz. Now since dv is a perfect differential, we can write in terms of del v del x dx plus del v del y dy plus del v del z dz. Now this can be written in this way. I del v del x plus j del v del y plus k del v del z dot I cap dx j cap dy k cap dz. Okay, now this can be written as del v dot dr. Okay, this we can write. Now another thing, that again we know that gradient of potential is a measure of force. That means F equals to minus dv dr. So from this we can write dv equals to minus f dr, that is f dot dr. So this can be written in this way. This is equal to this. Now simplifying, we get f plus del v dot dr, this is equal to 0. Now since dr is arbitrary, its coefficient will vanish. That means this term is 0. So we can easily write f equals to minus del v. So I have told that the central force is conservative and this force can be expressed as the gradient of some scalar potential. Okay, as the gradient of some scalar potential. So there is the proof, a second property, f equals to minus del v. Okay, now another property I have told yesterday, that for a central force field the particle must lie in a plane. How we can prove it? We know that angular momentum of the particle can be written in this way, L equal to r cross p. Now if we multiplying both sides by r, so what we get? By simply taking dot product with r, so what we get? L r dot L, this is equal to r dot r cross p. Okay, now from vector identity we know that a dot b cross c equal to b dot c cross a equal to c dot a cross b. So if we write it c dot a cross b, that is p dot r cross r, then we can write this. So this term becomes 0. So we can easily say that r is perpendicular to L. So we prove that r is perpendicular to L. It is clear that the motion is confined within a plane. Okay, since r is perpendicular to L, it is clear that this motion is confined in a plane. Motion is confined in a plane. Okay, so this we can write. So this is the third property. Now another property that we can tell is that angular momentum of the particle remains constant. How we can prove it? Simple, L equals to r cross p. Now differentiating both sides with respect to t, what we get? dl dt. Now d dt of a cross b, we can write a cross db dt plus dA dt cross b. That means this we can write. Now dp dt can be written as f. Now what will be dr dt? That is v. And what will be p? That is mv. So here v cross and v cross, that means this term vanishes. So we can simply write as r cross f. Okay, now in case of a central force field, this term can be written as r into r cap, and this force can be written as f of r into r cap. So r cap cross r cap means 0. So from which we can easily write L equals to constant. So we prove the another property that in a central force field the angular momentum of the particle remains constant. Okay, so these are the various properties of central force which I prove today. Okay, now in the next class I will discuss about other properties of central forces. Okay, so again I want to tell you that if you don't subscribe my channel, then kindly subscribe and share it to your friends. Okay, thank you.